6, 1944. Omaha Beach. 6:30 a.m. Private First Class Harold Baumgarten is drowning in chaos. He is 19 years old, a Jewish kid from the Bronx who lied about his age to join the army, and he is currently chest-deep in water that is turning red with the blood of his friends. The landing craft that carried him across the English Channel has just dropped its ramp, and the men who were standing in front of him are already dead, cut down in the first 3 seconds by something he has never heard before. It doesn't sound like a gun. It sounds like fabric ripping, a continuous, impossibly fast tearing noise that seems to come from everywhere at once. The sound is so fast that individual shots blur together into a single screaming roar, like a buzzsaw cutting through wood, like the world itself being torn apart. That sound is the MG-42, and in the next 6 hours, it will kill more American soldiers than any other weapon on the beach. Baumgarten throws himself into the water as bullets stitch the surface around him. He can see the tracers coming from the bluffs above, not individual rounds, but solid streams of light, rivers of fire pouring down onto the beach. The German machine gunners are firing in long, sweeping bursts that catch men in groups of 5 and 6, cutting them down before they can take a single step toward cover. The water around him is chaos. Men are screaming, drowning, dying. Some have been hit before they even left the landing craft, their bodies slumping against the men behind them. Others made it a few steps before the bullets found them, and now they float face down in the surf, their blood mixing with the salt water, their rifles sinking to the sandy bottom. Baumgarten sees a man he knows, a kid from Brooklyn named Sergeant Clarence Robertson, take a burst across the chest. The bullets don't just hit him, they seem to tear him apart, punching through his body with a violence that defies comprehension. Robertson doesn't fall so much as come apart, his body twisting and jerking as round after round finds its mark. The Americans have machine guns too. They have the M1919 Browning, a reliable weapon that fires 500 rounds per minute. The soldiers on Omaha Beach have trained with it, trusted it, believed it would be enough. It is not enough. The German MG-42 fires 1,200 rounds per minute, more than twice as fast as anything the Americans possess. A single German gunner can lay down more fire than 2 American machine gun teams combined. And the Germans have hundreds of these guns positioned in concrete bunkers overlooking the beach, their fields of fire carefully calculated to create interlocking kill zones that cover every square meter of sand. The Americans call it Hitler's Buzzsaw. The Germans call it the Hitler's Edge, Hitler's Bone Saw. The official designation is Maskenenguer 42, but numbers don't capture what this weapon is, what it does, what it feels like to be on the receiving end of its fire. What it feels like is death, pure, mechanical, industrialized death, delivered at a rate that the human mind cannot process. Baumgarten keeps moving. He doesn't know why instinct, training, the desperate animal need to survive. He pushes through the water, past the bodies of his friends, toward a beach that seems impossibly far away. The bullets keep coming, kicking up geysers of water around him, snapping past his head with sounds like angry hornets. He makes it to the beach. He doesn't know how. He throws himself behind a steel obstacle, one of the thousands of barriers the Germans have placed to stop tanks and landing craft, and tries to catch his breath. His heart is pounding so hard he can feel it in his throat. His hands are shaking. His uniform is soaked with water and blood that might be his own or might belong to someone else. The sound continues. That horrible ripping sound, coming from the bluffs above, announcing death with every burst. Men are still dying on the beach around him, cut down as they try to cross the open sand, their bodies joining the carpet of dead that is spreading across the shoreline. By the end of D-Day, Baumgarten will be one of the few survivors from his landing craft. He will be wounded 5 times, hit in the face, the arm, the leg, the foot, and the head. He will watch friends die in ways that will haunt him for the rest of his life. He will spend months in hospitals, years in recovery, decades trying to forget what he saw on that beach. And he will never forget the sound, that horrible ripping sound that announced the presence of the most effective infantry weapon of World War II. This is the story of the MG-42, a gun so far ahead of its time that American engineers tried to copy it, failed completely, and spent the next 3 decades trying to figure out what went wrong. It is a story of German engineering genius, American industrial arrogance, and the strange truth that sometimes the enemy simply builds a better weapon, and there is nothing you can do except count your dead. The MG-42 did not appear from nowhere. It was the product of a decade of German military thinking, a response to specific problems that had plagued the German armed forces since the end of the First World War. After Germany's defeat in 1918, the Treaty of Versailles imposed strict limitations on German military capability. The army was limited to 100,000 men. Tanks were prohibited. Aircraft were prohibited. And machine guns, the weapons that had defined trench warfare, that had killed millions of young men in the mud of France and Belgium, were strictly limited in number and type. But restrictions breed innovation. Unable to compete with potential enemies in quantity, German military planners focused obsessively on quality. They studied the lessons of the previous war, analyzed what had worked and what had failed, and developed doctrines that would maximize the effectiveness of whatever weapons they were allowed to possess. The key insight came from their analysis of infantry tactics. In World War I, machine guns had been primarily defensive weapons. They were heavy, water-cooled, crew-served monsters that required multiple soldiers to transport, set up, and operate. They were devastating against attackers. The machine gun was the primary reason why World War I became a war of trenches rather than movement, but they were almost useless for offensive operations. When the front lines moved, which happened rarely, the machine guns stayed behind. German planners envisioned a different approach. What if the machine gun could move with the infantry? What if it could be carried by a single soldier, set up in seconds, and used to support attacks as well as defend positions? What if the machine gun became the centerpiece of the infantry squad rather than a separate support element? This concept, the machine gun as the primary weapon of the infantry squad, with riflemen serving as support for the gun rather than the other way around, would revolutionize ground combat. But it required a new kind of weapon, lighter than existing designs, faster firing, easier to manufacture, and more reliable than anything currently in existence. The Germans had already taken the first step toward this goal with the MG-34, introduced in 1934. The MG-34 was a remarkable weapon by any standard. It was the world's first true general-purpose machine gun, capable of serving as a light machine gun when fired from a bipod, a heavy machine gun when mounted on a tripod, and an anti-aircraft weapon when mounted on a special carriage. It could be fed from belts or drums, fired from the hip or the shoulder, used by a single soldier or a full crew. The versatility was unprecedented. Previous machine guns had been designed for specific roles, light or heavy, offensive or defensive, ground or air. The MG-34 could do all of these things, switching between roles with simple changes of mount and feed system. A single weapon could replace what had previously required several different designs. It fired 7.92 X-57 Mauser ammunition at a rate of 800 to 900 rounds per minute, not as fast as some specialized weapons, but more than adequate for most purposes. It was accurate, reliable, and beautifully made. That last quality was also its greatest weakness. The MG-34 was manufactured to extremely tight tolerances, with many parts requiring extensive machining by skilled workers. Each gun required approximately 150 man-hours to produce, an enormous investment of labor for a single weapon. The manufacturing process used components that were expensive and difficult to source, requiring high-grade steel alloys and precision equipment that was in short supply. The weapon was, in a very real sense, a work of art. Every part was carefully fitted, every surface smoothly finished, every mechanism precisely calibrated. It was the kind of gun that master craftsmen took pride in building, the kind of weapon that reflected centuries of German metalworking tradition. But Germany was not preparing for a small war fought by craftsmen. Germany was preparing for a massive industrial conflict that would require millions of weapons produced as quickly as possible. The MG-34, for all its excellence, could not be manufactured in the quantities that modern warfare would demand. There was another problem as well. The MG-34's tight tolerances made it sensitive to environmental conditions. In the mud of the Eastern Front or the sand of North Africa, the weapon could jam if dirt or debris infiltrated its mechanism. The same precision that made it accurate also made it vulnerable, unable to function reliably in the harsh conditions of actual combat. The German military needed something else. It needed a weapon that combined the performance of the MG-34 with dramatically improved manufacturability and reliability. It needed a weapon that could be produced by the millions, by semi-skilled workers, using materials that were readily available. It needed a weapon that would work in any conditions, from Arctic cold to desert heat, from clean factory floors to muddy battlefields. It needed the MG-42. In 1937, the German army issued a requirement for a new machine gun that would address the MG-34's limitations while maintaining or exceeding its performance. The specifications were demanding. The new weapon had to fire at least as fast as the MG-34, preferably faster. It had to be at least as reliable, preferably more so. It had to be lighter and more portable. And most importantly, it had to be significantly cheaper and faster to produce. These requirements seemed almost contradictory. How could a weapon be better and cheaper at the same time? How could manufacturing time be reduced without sacrificing quality? How could costs be cut without compromising performance? The traditional firearms manufacturers, the companies that had been building guns for generations, that employed master craftsmen trained in techniques passed down through centuries, looked at the requirements and saw impossibility. They could build better guns, or they could build cheaper guns, but not both. The contract went to an unlikely candidate, Metal- und Lackierwarenfabrik Johannes Grossfuss, a company based in Döbeln, Saxony, that had previously manufactured metal lanterns and sheet metal products. Grossfuss had no experience whatsoever with weapons design. They had never built a gun of any kind. They knew nothing about firearms engineering or ballistics or military requirements. What they knew was metal stamping. The Grossfuss company specialized in a manufacturing technique that formed complex shapes from sheet metal using industrial presses. Rather than machining parts from solid blocks of steel, cutting away material until the desired shape emerged, stamping pressed flat sheets of metal into three-dimensional forms in a single operation. The technique was fast, cheap, and required relatively little skill to execute. Metal stamping was common in the consumer goods industry. It was how automobile body panels were made, how kitchen appliances were formed, how countless everyday objects were manufactured at scale. But it had rarely been applied to weapons, which were traditionally built using machining, forging, and other techniques that produced stronger, more precise parts. The lead designer on the Grossfuss project was a young engineer named Werner Gruner. He was not a gunsmith in the traditional sense. He had no experience with firearms design, no training in ballistics, no background in military weapons. He was an industrial engineer who understood mass production, who thought in terms of assembly lines and standardized components, who approached problems from the perspective of manufacturing efficiency rather than traditional craftsmanship. Gruner looked at the MG-34 and saw not a masterpiece of engineering, but a manufacturing nightmare. Every machined part represented wasted material, steel that had been cut away and discarded rather than used. Every precision-fitted joint represented hours of skilled labor that could have been spent elsewhere. Every tight tolerance represented a potential point of failure when the weapon encountered real-world conditions. His design philosophy was radical. If a part could be stamped rather than machined, stamp it. If a component could be welded rather than screwed, weld it. If a mechanism could be simplified without losing function, simplify it. Every design decision was evaluated not just on performance, but on manufacturability, on how quickly and cheaply the weapon could be built. The traditional firearms establishment was skeptical. Stamped parts were considered inferior to machined parts, weaker, less precise, unsuitable for the stresses of automatic weapon fire. Welded joints were considered less reliable than screwed or riveted connections. The whole approach seemed like a recipe for disaster, a shortcut that would produce a cheap but ineffective weapon. Gruner proved them wrong. The weapon that emerged from the Grossfuss factory was designated the MG42, and it was unlike anything the firearms industry had ever seen. On paper, the MG42 looked almost crude compared to the elegant MG34. Where the MG34 had smooth, machined surfaces that reflected light like mirrors, the MG42 had visible spot welds and stamped components with rougher finishes. Where the MG34 had precision-fitted parts that slid together with watchmaker accuracy, the MG42 had looser tolerances that allowed for easier assembly. Where the MG34 looked like a weapon built by craftsmen who took pride in their work, the MG42 looked like a weapon built by a factory. But appearances were deceiving. The MG42 was not a cheaper, inferior version of the MG34. It was a fundamentally different approach to the same problem, and in almost every way that mattered, it was superior. The manufacturing statistics alone were staggering. The MG34 required approximately 150 man-hours to produce. The MG42 required 75 man-hours, exactly half the time. The MG34 used 49 pounds of raw materials. The MG42 used 27, 5 pounds, just over half the material. The MG34 required extensive machining by skilled workers using specialized equipment. The MG42 could be assembled by semi-skilled laborers following standardized procedures, using equipment that was common in any industrial facility. This meant that Germany could produce 2 MG42s in the time it took to produce 1 MG34, using roughly half the material. In a war of attrition, where industrial capacity was as important as tactical brilliance, this advantage was enormous. The cost savings were equally impressive. The MG34 cost approximately 327 Reichsmarks to manufacture. The MG42 cost 250 Reichsmarks, a reduction of nearly 25%. When multiplied across hundreds of thousands of weapons, these savings added up to resources that could be directed elsewhere. But the real genius of the MG42 was not its manufacturability, it was its rate of fire. The MG34 fired 800 to 900 rounds per minute, already impressive by the standards of the time, faster than most comparable weapons. The MG42 fired 1,200 to 1,500 rounds per minute, depending on the variant and conditions. This was not a marginal improvement. It was a quantum leap, a transformation of what a machine gun could do. To put this in perspective, the American M1919 Browning, the standard U.S. medium machine gun of World War II, fired approximately 500 rounds per minute. The British Bren gun fired about 500 rounds per minute. The Soviet DP-27 fired about 550 rounds per minute. The MG42 fired more than twice as fast as any of these weapons, in some variants, nearly 3 times as fast. The high rate of fire was achieved through a combination of design innovations that worked together to create something greater than the sum of its parts. The bolt mechanism was the key. The MG42 used a system of rollers that locked into recesses in the barrel extension, securing the bolt in place during firing. When the weapon discharged, gas pressure pushed the barrel and bolt backward together. After a short distance, the barrel stopped and cammed surfaces forced the rollers inward, unlocking the bolt and allowing it to continue rearward alone. This roller-locked system allowed for a shorter bolt travel than traditional designs, which meant faster cycling. The bolt didn't have to move as far before it could return, so it could complete more cycles in a given time. Combined with careful tuning of the recoil spring and other components, this produced the extraordinary rate of fire that made the MG-42 unique. The recoil-operated action was tuned for maximum speed rather than maximum reliability, accepting a slightly higher jam rate in exchange for dramatically increased firepower. This was a deliberate trade-off. German engineers understood that a weapon which occasionally jammed but fired twice as fast was more effective overall than a weapon which never jammed but fired half as fast. The result was a weapon that fired so fast that individual shots were nearly impossible to distinguish. The sound was not the rhythmic hammering of a conventional machine gun, the steady thump 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 that soldiers had learned to recognize and fear in World War I. It was a continuous roar, a screaming tier of noise that overwhelmed the senses and terrorized anyone unfortunate enough to be on the receiving end. This psychological effect was not accidental. It was a feature. German engineers understood that warfare was as much about psychology as physics. A weapon that terrified the enemy was more effective than a weapon that merely killed them. Fear caused hesitation, paralysis, mistakes. A soldier who was frozen with terror was a soldier who could be killed at leisure. The MG-42 induced terror as reliably as it induced casualties. Allied soldiers who survived encounters with the weapon reported nightmares, flashbacks, and lasting psychological trauma that went beyond ordinary combat stress. The sound became a trigger for panic. Men who heard it would freeze, dive for cover, sometimes refuse to advance even when ordered. This was not cowardice. It was a rational response to an irrational threat. The MG-42 was simply too fast, too deadly, too overwhelming for normal human responses to cope with. The brain recognized the sound as a signal of extreme danger and responded accordingly, overriding conscious control with primal survival instincts. The weapon was adopted by the German army in 1942 and immediately deployed to every front where German forces were engaged. By 1943, it had become the standard squad automatic weapon, the backbone of German infantry tactics, the gun around which entire units were organized. German infantry doctrine was rebuilt around the capabilities of the MG-42. The traditional infantry squad, in which riflemen were the primary combat element and machine guns provided support, was inverted. Now the machine gun was the primary weapon, and the riflemen existed to support it, carrying ammunition, providing security, helping the gunner move and set up. A standard German infantry squad consisted of 10 men. A squad leader, a machine gunner, an assistant gunner, and 7 riflemen. The machine gunner carried the MG-42 itself. The assistant gunner carried spare barrels and helped feed ammunition. The riflemen carried additional ammunition boxes and provided security for the gun team. The squad carried 1,500 rounds of ammunition as standard, enough for about 90 seconds of continuous fire at maximum rate, or several minutes of controlled bursts. When the ammunition ran low, riflemen would resupply from company reserves. The entire squad existed to keep the MG-42 firing. This organization reflected a fundamental truth about infantry combat. Automatic weapons dominated the battlefield. A single MG-42 could suppress an entire enemy platoon, could cut down an attacking squad in seconds, could hold a position against forces that outnumbered it many times over. Everything else was support for that capability. The Allies discovered this truth the hard way. The American military first encountered the MG-42 in significant numbers during the North African campaign in late 1942 and early 1943. The fighting in North Africa was a learning experience for American forces, many of whom had never seen combat before. They faced not only the German military machine, but also the realities of modern warfare: the speed, the violence, the confusion, the terror. Many lessons were learned in those desert battles, and one of the most important concerned the German machine gun. American infantry, equipped with the M1919 Browning and the Browning automatic rifle, found themselves consistently outgunned in firefights with German units. The disparity was not subtle. It was not a matter of slight disadvantage that could be overcome with better tactics or superior numbers. It was a fundamental mismatch in capability that made every engagement more costly than it should have been. The German machine guns fired faster. They had better effective range. They were more mobile, easier to set up, quicker to bring into action. In the time it took an American machine gun crew to get their weapon operational, a German crew could have fired hundreds of rounds. The reports multiplied as the war progressed. From North Africa, from Sicily, from Italy, from France. The same story. At Kasserine Pass in February 1943, American forces suffered their first major defeat of the war against German troops. Many factors contributed to that disaster: poor leadership, inadequate training, bad terrain. But the MG-42 played its part. American soldiers trying to advance against German positions were mowed down by machine gun fire that they had never experienced before, that their training had not prepared them for, that their own weapons could not match. The problem was not courage or training or tactics. American soldiers were as brave and well-trained as any in the world. The problem was technology. The MG-42 was simply a better weapon than anything in the American arsenal, and no amount of bravery could overcome that fundamental disadvantage. The American response was predictable. If the Germans have a better gun, we'll copy it. In 1943, the U.S. Army Ordnance Department initiated a program to reverse engineer the MG-42 and produce an American version. The reasoning was straightforward. If the German design was superior, then American industry, the most productive manufacturing base in the world, would simply adopt that design and produce it in overwhelming quantities. This approach had worked before. American industry was expert at taking good designs and mass-producing them. The Liberty ships that were carrying supplies across the Atlantic were based on a British design. The P-51 Mustang fighter that would eventually dominate the skies over Europe used a British engine. American manufacturing genius lay not in innovation, but in execution, in taking proven concepts and producing them faster, better, and in larger quantities than anyone else. Surely the same approach would work with the MG-42. Captured weapons were shipped back to the United States, where teams of engineers at Springfield Armory disassembled them, measured every component, and documented every mechanism. They photographed parts, created technical drawings, analyzed metallurgy, studied manufacturing marks. The goal was to create exact duplicates that could be manufactured in American factories using American materials and American production methods. The project was given high priority. The need for a better machine gun was urgent, and American industry was confident that it could outproduce German industry in any category. If the Germans could build the MG-42, Americans could build it faster, better, and in larger quantities. The confidence was not misplaced. American industry in 1943 was performing miracles of production that would have seemed impossible just a few years earlier. Factories that had built automobiles were now building tanks. Shipyards were launching new vessels faster than German submarines could sink them. Aircraft plants were producing thousands of planes per month. If any industrial base in the world could copy the MG-42, it was America's. The first problem appeared almost immediately. The MG-42 was chambered for the German 7.92x57 Mauser cartridge, a round that had been the standard German military rifle and machine gun ammunition since the 1890s. American forces used the 3006 Springfield cartridge, which had a slightly different dimension and produced slightly different pressures. The two cartridges were similar but not identical. The 3006 was slightly longer and generated slightly higher chamber pressures. These differences might seem minor, fractions of an inch, small variations in pressure curves. But in a weapon operating at 1,200 rounds per minute, small differences became large problems. Converting the MG-42 to fire American ammunition was not a simple matter of changing the barrel. It required modifications to the bolt, the feed mechanism, the recoil system, the chamber dimensions, and numerous other components. Each change affected other components. creating cascading modifications that spread through the entire design. American engineers were confident they could make these changes without compromising the weapon's performance. The engineering seemed straightforward. The cartridges were similar enough that the basic operating principles should transfer. It was just a matter of adjusting dimensions and tolerances to accommodate the new ammunition. They were wrong. The American version was designated the T-24. Prototypes were built at Springfield Armory and Rock Island Arsenal, using captured MG-42s as templates. The weapons looked almost identical to the German originals. Same stamped receiver, same barrel shroud, same general appearance. Only an expert could tell them apart at a glance. But when the prototypes were tested, they failed catastrophically. The guns jammed. They misfired. They overheated far more quickly than the German originals. The rate of fire was erratic, varying wildly from burst to burst. Accuracy was poor, with rounds spraying unpredictably rather than following the controlled patterns that made the MG-42 effective. And most alarmingly, they sometimes exploded. The receivers, the stamped steel bodies that held the entire mechanism together, cracked and ruptured under the stress of firing. Metal fragments sprayed outward, endangering the soldiers testing them. In several cases, catastrophic failures destroyed the weapons completely, reducing them to twisted hunks of useless metal. The engineers were baffled. They had copied the design exactly, or so they believed. Every dimension was correct. Every component was manufactured to specification. The materials were equivalent to those used by the Germans. The guns should have worked, but they didn't. The problem, it turned out, was not in any single component. It was in the relationships between components, in the tolerances and clearances and timing that made the weapon function as a system rather than a collection of parts. The MG-42 had been designed as a complete system, with every element tuned to work with every other element. The rate of fire, the recoil forces, the heat dissipation, the feed timing, the bolt velocity, the barrel harmonics. All of these factors were interconnected, each one affecting all the others in ways that were not immediately obvious. Changing the ammunition changed the pressure curves in the barrel. This changed the forces acting on the bolt, which changed the timing of the unlocking sequence. The different timing changed the relationship between bolt velocity and feed timing, which caused rounds to be stripped from the belt at the wrong moment. The misaligned feeding caused jams. The different pressures caused overheating. The cumulative stresses caused failures. German engineers had spent years perfecting these relationships. They had conducted thousands of test firings, made countless small adjustments, accumulated knowledge through trial and error that could not be captured in blueprints or specifications. This knowledge was embedded in the weapon's design, not in written documentation, but in the specific choices that made everything work together. American engineers, working from captured examples and incomplete documentation, had no way to understand these relationships or replicate the development process that had produced them. They could copy the dimensions, but not the understanding. They could reproduce the parts, but not the relationships between parts. This is the fundamental limitation of reverse engineering. You can measure what exists, but you cannot see the process that created it. You can duplicate the product, but you cannot duplicate the knowledge that produced the product. The MG-42 was not just a collection of components. It was the physical expression of thousands of hours of development, testing, and refinement. Copying the components without understanding the development was like trying to reproduce a symphony by photographing the musicians. You might capture the appearance, but you would miss the music entirely. The T-24 project was not officially cancelled, but it was effectively abandoned. The prototypes were too unreliable for combat use, and fixing them would have required a complete redesign, essentially developing a new weapon from scratch, which would take years to complete. By the time such a redesign could be finished, the war might well be over. American soldiers would continue to fight with the M1919 Browning and the Bar, weapons that were reliable and well-made, but hopelessly outclassed by the German gun they faced. The failure to copy the MG-42 had immediate consequences on the battlefield. Throughout 1943 and 1944, American forces continued to suffer disproportionate casualties in engagements where German machine guns were a factor. The situation was particularly severe during offensive operations, where American troops had to advance against prepared German positions. The mathematics were brutal. A German machine gun position could be set up in minutes, camouflaged and fortified, with interlocking fields of fire that covered all approaches. Attacking such a position required either overwhelming firepower, artillery, air support, armor, or infantry willing to accept heavy casualties to close the distance and eliminate the gun. When such support was available, German positions could be neutralized, but support was not always available. In the bocage country of Normandy, where thick hedgerows blocked lines of sight and restricted movement, tanks and artillery often could not reach positions that infantry needed to take. In urban combat, where buildings provided cover for defenders and restricted maneuver for attackers, machine guns dominated. The D-Day landings were the most dramatic example of what the MG-42 could do. On Omaha Beach, German forces had constructed an elaborate defensive system that took full advantage of the terrain. The beach was overlooked by bluffs that provided excellent observation and fields of fire. Concrete bunkers protected machine gun positions from naval bombardment. The guns themselves were positioned to create interlocking kill zones that covered every meter of the landing area. The American plan assumed that naval and air bombardment would neutralize these defenses before the landings. It didn't work. The bombardment was less effective than hoped. Bombs and shells missed their targets, failed to penetrate fortifications, or simply did less damage than anticipated. When American troops hit the beach, the German defenses were largely intact. What followed was a massacre. The first waves of American infantry were cut down almost immediately. Landing craft dropped their ramps, and men were killed before they could take a step. Those who made it into the water were hit while wading towards shore. Those who reached the beach were hit while trying to find cover. The MG-42s fired continuously, their crews working methodically through the targets, reloading and changing barrels as needed. The American casualties on Omaha Beach were approximately 2,400 killed and wounded, far higher than any other landing beach on D-Day. Many of those casualties were caused directly by MG-42 fire. The gun had done exactly what it was designed to do: create a killing ground that advancing infantry could not cross. The beach was eventually taken, but only after hours of brutal fighting and the expenditure of enormous courage. Small groups of soldiers managed to penetrate the defenses, working their way up the bluffs through gaps in the German fire. Naval destroyers moved dangerously close to shore to provide direct fire support. Rangers scaled cliffs under fire to outflank defensive positions. Slowly, painfully, the American forces gained a foothold. But the cost was higher than it should have been, and the MG-42 was a major reason why. The psychological impact of the MG-42 extended far beyond its physical casualties. Soldiers who survived encounters with the weapon reported lasting trauma that went beyond ordinary combat stress. The sound, that distinctive ripping roar, became a trigger for flashbacks and nightmares. Veterans described hearing it in their sleep decades after the war, waking in cold sweats with the memory of friends dying around them. The U.S. Army recognized this psychological dimension and attempted to address it through training films and educational materials. One film, produced in 1944, directly addressed the fear that American soldiers felt when facing the MG-42. The film acknowledged that the German gun was faster than American weapons. It showed the MG-42 being fired, demonstrated its rate of fire, explained its capabilities. But then it attempted to reassure soldiers that the high rate of fire was not as dangerous as it seemed. The gun overheated quickly, the film explained, requiring frequent barrel changes. It consumed ammunition at an enormous rate, making resupply a constant problem. Its accuracy suffered at extreme rates of fire. American weapons might be slower, but they were more sustainable, more accurate, more reliable. The film's narrator adopted a dismissive tone. "Sure, it sounds impressive," he said of the MG-42, "but don't let it scare you. It's just a machine gun, like any other machine gun, and it can be beaten." The reassurance was not entirely convincing. Soldiers who had faced the MG-42 knew that the theoretical weaknesses described in training films didn't matter much when the gun was firing at you. Overheating was a problem for the German crew, not for the Americans being shot at. Ammunition consumption was a logistical concern, not a tactical one in the heat of battle. The film's attempt to minimize the weapon's effectiveness rang hollow to men who had seen what it could do. But the army had to do something. Soldiers who were paralyzed with fear were soldiers who couldn't fight. The films and training materials were imperfect solutions to a real problem, the problem of facing a weapon that was genuinely superior to anything you possessed. The failure to copy the MG-42 was not the end of the story. It was the beginning of a longer, stranger tale that would extend well beyond World War II. After the war ended, American military planners conducted extensive studies of German weapons technology. The MG-42 was examined in detail, its design principles analyzed, its performance characteristics documented. The conclusion was unambiguous. The German weapon was superior to anything in the American inventory, and the United States needed to develop something comparable. But the attempts to copy the MG-42 directly had failed. Simply duplicating the German design would not work. American engineers needed to understand why the weapon worked, not just how it was built. This understanding came slowly, through years of research and experimentation. Engineers studied the bolt mechanism, the feed system, the barrel design, the manufacturing processes. They conducted test firings, measured performance parameters, analyzed failures. Gradually, they built up the knowledge that German engineers had accumulated through their own years of development. The key insight was that the MG-42's performance came not from any single feature, but from the integration of multiple features into a coherent whole. The rate of fire, the operating mechanism, the barrel design, the ammunition feed, all of these elements had to work together in precisely the right way to produce the weapon's devastating effectiveness. American engineers eventually developed their own weapon based on these principles. The M60 machine gun, introduced in 1957, borrowed heavily from the MG-42 design, particularly the feed mechanism and the barrel change system. It also incorporated elements from another German weapon, the FG-42 automatic rifle, including the operating rod and bolt mechanism. The M60 was a capable weapon, but it was not the equal of the MG-42. It was heavier, about 23 pounds compared to the MG-42's 25 pounds, but with a slower rate of fire that meant less firepower per pound. It was more complex, with more parts that could break or malfunction. Its rate of fire, around 550 rounds per minute, was less than half that of the German gun. American soldiers who used the M60 in Vietnam often complained about its performance. The weapon was prone to jamming, particularly in the wet, dirty conditions of jungle warfare. Its tendency to malfunction at critical moments earned it the nickname, the pig, not a term of affection, but a commentary on its stubbornness and unreliability. Meanwhile, the MG-42 itself continued in service. The German military, reconstituted as the Bundeswehr in 1955, adopted a modified version of the MG-42 chambered for the NATO Standard 7.62x51 cartridge. This weapon, designated the MG3, remained in production and in service into the 21st century, a testament to the enduring excellence of the original design. The MG3 fires at approximately 1,200 rounds per minute, essentially unchanged from the World War II original. It is still manufactured by Rheinmetall and has been adopted by dozens of countries around the world. More than 80 years after its introduction, the basic MG-42 design remains competitive with weapons developed decades later. This longevity is remarkable. Most weapons become obsolete within a few decades, replaced by newer designs that incorporate improved materials, manufacturing techniques, and operating principles. The MG42 has survived because its fundamental design was so sound, so well conceived, so perfectly suited to its purpose, that subsequent improvements have been marginal at best. The American military, for its part, eventually replaced the M60 with the M240, a weapon based on the Belgian FN mag, which was itself heavily influenced by the MG42. The M240 is a better weapon than the M60, more reliable, easier to maintain, better suited to the demands of modern combat. But its rate of fire, around 650 rounds per minute, is still roughly half that of the original German design. 80 years after D-Day, American soldiers still carry machine guns that fire slower than the weapon their grandfathers faced on Omaha Beach. The story of the MG42 raises uncomfortable questions about military technology and industrial capability. The United States in World War II was the most productive industrial economy in human history. American factories produced more tanks, more aircraft, more ships, and more weapons than any other nation. The scale of American production was decisive in winning the war. The sheer volume of materiel that American industry could deliver overwhelmed enemies who could not compete in quantity. But quantity is not quality. American industry excelled at mass production, at taking a proven design and manufacturing it in enormous quantities. It was less successful at innovation, at creating new designs that pushed the boundaries of what was possible. The MG42 was not a triumph of mass production. It was a triumph of design innovation, of engineers who reimagined what a machine gun could be and then created something that had never existed before. German industry in World War II was far less productive than American industry, but in certain categories it was far more innovative. This pattern repeated across multiple weapons systems. German tanks, while fewer in number than Allied tanks, were generally more capable in individual engagements. The Tiger tank and the Panther tank outclassed American Shermans in armor, firepower, and protection. German aircraft, while overwhelmed by Allied numbers, often incorporated advanced features that Allied designers had not yet mastered. German rockets, submarines, and guided missiles were years ahead of anything the Allies possessed. The lesson is not that Germany should have won the war. It lost, decisively, because industrial capacity ultimately matters more than technological sophistication. The Allies won by building more weapons, not better weapons. Quantity has a quality all its own, as Stalin supposedly observed, and the quantities that American industry could produce were overwhelming. But the lesson is also that industrial capacity is not sufficient by itself. If your enemy has a weapon that is dramatically better than yours, no amount of production can fully compensate. American soldiers on D-Day were killed by MG-42s because American engineers had not built an equivalent weapon, and American factories, for all their productive capacity, could not manufacture something that didn't exist. The MG-42 was a reminder that war is not just about logistics and strategy. It is also about engineering, about the quality of the tools that soldiers carry into battle. And sometimes, the enemy simply has better tools. The broader implications of the MG-42 story extend far beyond World War II. The weapon demonstrated that manufacturing excellence and engineering excellence are not the same thing. American industry could manufacture anything. Given a proven design, American factories could produce it faster and in greater quantities than anyone else. But American engineering, at least in this specific domain, could not match what German engineers had achieved. This gap was not inevitable. American engineers were as talented as their German counterparts, and American industry had access to equal or greater resources. The difference was focus. German military development had concentrated resources on specific areas, pursuing excellence in depth rather than breadth. The German military could not match American production in aggregate. but it could outmatch American development in specific categories. The MG-42, the Tiger tank, the Me-262 jet fighter, the V-2 rocket. These were all examples of German engineering exceeding Allied equivalents in particular domains, even as Germany fell behind in overall industrial output. This trade-off between depth of excellence and breadth of capacity is a recurring theme in military history. Nations must choose how to allocate their development resources, and different choices produce different outcomes. Germany chose depth, America chose breadth. Both choices had consequences. The American approach won the war because breadth ultimately matters more than depth. It doesn't matter if your enemy has better tanks if you have 10 times as many tanks. It doesn't matter if your enemy has better machine guns if you can bury their positions under artillery fire and overwhelm their defenses with sheer numbers. But the German approach left a legacy that outlasted the war itself. The MG-42 design continued in service for 80 years. German engineering principles, particularly in metallurgy, optics, and precision manufacturing, were absorbed by Allied nations after the war and influenced subsequent development for decades. The tension between these approaches continues today. Modern militaries face the same trade-offs that faced their World War II predecessors. Invest in breakthrough technologies that might provide decisive advantages, or invest in proven technologies that can be produced in quantity. There is no single correct answer. The optimal choice depends on circumstances, resources, and strategic objectives. But the MG-42 stands as a reminder that engineering excellence matters, that a weapon which is genuinely superior can make a difference on the battlefield, even against an enemy with greater industrial capacity. The soldiers who faced the MG-42 understood this in the most direct way possible. They learned that courage and determination were not always enough, that sometimes technology determined outcomes regardless of human factors. They learned that the enemy had built something better and that they had to face it anyway. What they did not know, what they could not know, was that their own military was trying desperately to copy the weapon that was killing them and failing completely. The sound of Hitler's Buzzsaw echoed across the battlefields of Europe for 3 years, from North Africa to Berlin. It killed tens of thousands of Allied soldiers. It broke the will of countless others. It demonstrated, in the most brutal way possible, what happened when engineering excellence met industrial capacity on the battlefield. Industrial capacity won, eventually. The Allies won the war through production and logistics and strategic bombing, and 100 other factors that had nothing to do with infantry weapons. The MG-42 could not win the war for Germany any more than any other single weapon could. But it made a difference. It made the war longer and bloodier than it might otherwise have been. It killed soldiers who might have survived if their enemy had been equipped with inferior weapons. It left psychological scars that lasted for decades. And it proved that sometimes the enemy simply builds a better gun. The last veterans of World War II are passing away now, taking their memories with them. The sound of the MG-42, that terrible ripping sound that haunted so many of them, will soon exist only in recordings and reconstructions, no longer in living memory. Harold Baumgarten, the young soldier from the Bronx who survived Omaha Beach, lived until 2016. He was 90 years old when he died, having spent more than 7 decades carrying the memories of that day on the beach. In interviews throughout his later years, he returned again and again to that sound, the ripping, tearing roar of the German machine guns that had killed so many of his friends. "You never forget it," he said in a 2014 interview. 70 years later, and I still hear it. I'll be falling asleep, and suddenly I'm back there in the water, and I can hear those guns firing. That sound, it was like nothing else. It wasn't like the movies. It was like the whole world was being torn apart. Other veterans told similar stories. The MG-42's distinctive report became a kind of auditory scar, a sound that could trigger flashbacks and nightmares decades after the war ended. Psychologists who studied combat trauma noted that veterans of the European theater often reported specific triggers, related to high-pitched, rapid sounds. Triggers: